Okay, let's not waste any more time. Those who are not in, they're gonna get the recording. This time around, I will try to make sure I send uh, the video on WhatsApp so that it could be easier to be accessed by everybody. Okay, as I've said the last time, today's lesson is about Euclidean geometry, or some they call it cycle geometry. It's the same thing. So this chapter consists of many theorems. So you need to know many theorems in order for you to answer many questions under this chapter. So most of the theorems which comprised on this chapter are grade 11 theorems. There are about 12 theorems from grade 11, and there are about 6 theorems from grade 12. So of which you are expected to know all of them for you to be able to answer all the questions. So now I'm going to take you through about 5 theorems under Euclidean geometry, and we do some questions based on those theorems, of which we will also try other questions as exercise. Okay, then now the first theorem which you are expected to know under Euclidean geometry, it's the theorem of midpoint. So what does the theorem of midpoint says? It says that if you have a chord and there's a line that comes from the center of the circle, go straight and cross the chord, then now with that information, you will have been given that the line AB, which is a chord, is perpendicular to the line OB. So in other words, we have a 90-degree here. So if that is the case, then you can then conclude that the line AB, the distance from here to A up to B, is the same, or it's equal to the distance from B to C. So that information is very critical. Where can you be expected to use this? You can use the information from this theorem only if you have a chord, and then from that chord there must be a line which comes from the center of the circle. It then crosses the chord, and when it crosses the chord, you must have a 90-degree, or the line AC must be 90-degree perpendicular to the line OB. That must be the information which is given. Then if that information is given, you can then say the distance AB is equal to the distance BC. So then now the reason you can provide for this conclusion is that the line from the center is perpendicular to the chord. That is the conclusion which you can make, where you can justify that the distance AB is equal to distance BC. That is the case because the line from center of the circle is perpendicular to the chord. Are we all together on the first theorem?
Yes.
Okay. Then now the second theorem is just the reverse of the first theorem I explained to you just now. So instead of being given the information that the line AC is perpendicular to the line OB, now it's other way around. You are now given the information that the distance AB is equal to the distance BC on the chord. Then now, if that is the case, then you can conclude that the line AC is perpendicular to the line OB. In other words, this is the converse of the first theorem I told you just now. So here, if AB is equal to BC, then you can conclude that the line, the chord AC is perpendicular to the line OB. Why? Each time when you say a conclusion or when you give conclusion, you need to give a reason. So the reason for this to be the case is that the line from center to the reason is that we have a line from center to midpoint of chord. So the line from this center O to the mid point of the chord, which is indicated by B there. Another reason you can give is that OB is perpendicular to AC. So that reason, it also qualifies to be given on this kind of questions. So take note of this theorem, the first theorem I gave you there. So the second theorem again is the original theorem with its converse. So you must be able to understand the two theorems. So now let's go to the second theorem. I will do some example with regard to the first theorem, but now let me also remind you about the second theorem, which is very popular. And I'll do questions for this at later stage after we finish covering this. So now here, let's see. The center of this cycle is at O. So now, on this center O, we have two angles. On the center O, we have two angles. The first one is O1, which is given down here. And then we have O2, which is given up there. So then what can you conclude about this? So the conclusion is that, or the theorem which can establish that if you are given the points A, B, C, D, and E on the points at the cycle, then you can have the angle at the center, which is O1, equal to 2 times the angle at the circumference. See where we have the circumference here. So the center of the angle here is O1, so it's giving this angle here, which is E, and also giving the angle down here, which is angle D. So now this theorem, it says that the angle at the center, we have two angles at the center, remember. So the first angle at the center, which is angle O1, it's equal to twice the angle at the circumference. What are the angles at the circumference here? So the angle at the circumference is angle E and angle D. So therefore, O1, it would be equal to 2 times E. And again, it would be the same as to say 2 times D. Why? because angle at the center, it's twice the angle at the circumference. The angles at the circumference here is angle E and angle D. Let me not rush to explain this because I want you guys to follow with regard to what I'm explaining to you now. So here I'm explaining the theorem for the angle at the center is twice the angle at the circumference. So angle at the center, we are given two angles at the center. So the first angle at the center is O1, which is going to be twice angle E or twice angle D. So that's the first one. The second one, let's use the angle at the center as angle O2. Take note of this because it's another important information which you have to take note of. So the other angle O at the center of O2 at the center of the cycle is given there. So this angle will be twice angle B. It's going to be twice angle B there. See the position for D, for B in this case. So if we have O2 here, therefore O2 will be equal to 2B, which is the angle at the circumference. So you give the same reason, but the approach is different. Okay, let me write this on the board so that I can be able to explain it in the simplest terms possible. Are you able to see the whiteboard? Can you see the whiteboard? Okay.
Yeah.
Let me unshare the screen and explain this theorem on the board so that I can explain it clearly, because it's another important theorem which you have to take note of. Okay, so we have a cycle. We're given a cycle, and this cycle is having a center O. So then now, we then construct a triangle inside that cycle. So we have O, let's say this is O1 and this is O2 for simplicity. So we have O1 and O2. So now the angle at the center of the cycle is twice the angle at the circumference. If we say this is B, A, this is B, and this is C. So now O1 will be equal to 2 times C. Why? Because angle at the center, is equal to 2 times angle at circumference. So that is the reason why we say O1 is equal to 2 times C. Why? It's because angle at the center is twice the angle at the circumference. I'm emphasizing this because it's very important. Now, the converse of that theorem is when we have this. See, I'm now constructing another shape here. So down here, let's say we have a point D. So instead of using O1, we can then use O2. So O2 will be equal to 2D. Why O2 will be equal to 2D here? Again, we use the same theorem. Angle at center is twice angle at circumference. So it's the same reason. But now, the angle we used here is this big angle here, which is O2. So O2 is equal to 2 times D2. Let me find out if you understood the theorem I gave just now on the board.
Yes.
Are you okay with the theorem I gave on the board?
Yes.
Okay, wonderful. Okay, I gave you 2 theorems. Let me go to the third theorem before we go to the question. So is this theorem where angles are subtended by the chord? Let me go up a little bit. So it is this theorem here. So inside the circle, we are having 2 triangles. So, and in these 2 triangles, we have just one side. We have just one side in each of the triangles which are equal. So in this case, we're given that AB is equal to DE. So if AB is equal to DE, therefore, the angle opposite to that side, they are then equal. So which in this case, the angle opposite to AB is C. And here the angle opposite to ED is F. So in that case, it means C and F, they will be equal. So what is the reason for making these angles to be equal? Is because the 2 angles, they are subtended by what? By the same chord. They are the same chord because they are equal. So AB is equal to DE. Therefore, because these 2 sides are equal, it simply tells us that C and F will be equal in that case. So the reason is because AB and DE, they are subtended by the same chord. Okay, let me write this on the board again for simplicity, because I want to emphasize this theorem because they are very important, even in grade 12. They are for grade 11, but you must take note of this theorem even for grade 12. So in simple terms, you might be having something like this. So it's a triangle inside ABC. So then now we have another triangle again. So, but these triangles, you can see they are sharing what? They are sharing a BC. These two triangles, triangle ABC and triangle BCD, they are sharing the same chord, which this chord is BC. Then if they are sharing the same chord, it means the angles opposite to that chord, they are equal. Therefore, A and D, they are equal. Why? Same chord. Same chord or equal chord is the same. So you can even mention that it's chord BC. So it's exactly the same theorem which they indicated there. They only differ because they decided to write these triangles separately. So let's say we have A, we have B, we have C, and then here we have D, we have E, we have F. Okay, then now tell me, if we are saying that FE is the same as AC, okay, let me say EF is the same as AC, then can you tell me the angles which are going to be equal? If EF is the same as AC, which angles will be equal in this case?
D and C.
It will be angle what?
Is that a D next to B?
Yes, this is D.
Won't it be DC? The angles that are equal.
It will be, so we are having AC, which is equal to EF. So which angles are they going to be equal in this case?
B and D.
B and D, yes. So B will be equal to D. And the reason for these two angles to be equal is because they are subtended by the equal chord or by the same chord. And these are called the same chords because they are equal in length. So you must take note of this theorem, it's very important. So they can write it in this form or they write it in that form. So just be mindful of the fact that if we are having the same chord, therefore they must have equal length. When we do examples, you'll see what I'm explaining are very simple. Okay. Okay. Let me give you the last theorem before we go to the questions. Another popular theorem is this one for semi-cycle. So now, if this theorem, it says that if we're having a triangle inside the cycle, and on this triangle we have a diameter, is there anyone who knows what is a diameter? What is a diameter? What is a diameter? Okay, let me explain it to you. So the diameter is a line that passes through the center of the cycle and it goes to the circumference of the cycle. Like here, AB would be a diameter. Why? Because it's passing through the cycle. So now, if you have a diameter, and then now from this diameter, you can then conclude that this angle C, which is a angle formed at the circumference of the circle, is going to be equal to 90 degrees. So it's a must that if you are having a diameter, then the angle that is going to be formed at the circumference of the circle is going to be equal to 90 degrees. Why? Why that is the case? So the simple reason to substantiate your answer is that this is angle in a semicircle. So the angle we have for C is equal to 90 degrees because it's an angle in a semicircle. Okay, now we have a converse. We have a converse theorem of this theorem I explained just now. So the converse of that theorem is when we are now having the conclusion of that. So let's say we are now having an angle which is equal to 90 degrees. So if we are having an angle C which is equal to 90 degrees, that simply tells you that the opposite side to that angle is going to be a diameter. So the side AB, it will be a diameter only if C is equal to 90 degrees. So why do you say that? So we are concluding that the angle C equal to 90 it is having an opposite side of a diameter. Why? Because we have a chord which subtends a 90 degree. So it's another important conclusion which you have to take note of. Let me also explain this on the board, and then from there we then go to the example that requires these theorems I've explained to you just now. Okay, so we have a circle, and then from that circle we have a chord, which a chord is a line that passes through the center of the circle and it goes to the circumference. Then from there, if you are given a chord or a diameter in this case, a diameter AB. So now, if you are having a diameter AB, then that simply tells you that angle C at the circumference, it must be equal to 90 degrees. Why it must be equal to 90 degrees? Because we have angle in a semicircle. So because this is half of the full circle, this is half of the full circle. So C will be equal to 90 degrees because we have an angle in a semicircle. So the converse of this is when you are given that C is equal to 90 degrees, then you can make a conclusion that the opposite side to this angle C is a diameter. So this information is very critical. Now, before we go to any questions, can you ask me any question with regard to the few theorems we have covered just now?
The one that we were doing, yeah. Is it the second theorem?
I did not hear you properly. What did you say?
The one we were doing, got the second theorem, the circle at the bottom.
Yes.
Where B is angle D, right?
This one.
On the study guide, if you can go back to it, right?
Yeah.
Yeah, I saw on the study guide, like they said, like for example, on the study guide, it was said C is equals to D. So now I'm just confused when you say B is equals to D. Just explain that situation.
Yes, exactly. I knew about that issue. Because you can see, I changed the position for the lines which are equal. You see, instead of saying AB is equal to FE, I now said AC is equal to EF.
Oh, which therefore makes BD equal. And
Yeah,
B and
definitely.
D equal.
So it's because I swapped this. Otherwise, if instead of AC, I said AB, then now it means C was going to be equal to what? To be equal to D.
Okay.
You see that?
Yes.
Yeah, exactly. Ask me any question before we attempt some problems that I have here. Are you all fine with the theorems I gave just now? Okay. Let me brush through to the questions that we can answer just now. Let me send them to the WhatsApp. Okay. I will answer the questions with the theorems we have covered just now. Like question number 1. Let's answer question number 1 together. So after that question, you will then answer the other question that comes after that. Okay, let's check. We are having O, which is the center of the cycle. So now AOM is perpendicular to PQ, where OP is equal to 50 millimeter. And we are also given that OM is equal to 30 millimeter. Okay. We are given this shape. PMOQ. So now the first question there requires us to calculate for PM. And then the second one, it requires us to give the length of PQ. These are the two questions which I'm going to answer with you just now. Let me take you back to the information that we have here. This cube is here, man. Otherwise, if it's there, it's not going to make any sense. So I believe you are aware of this diagram we have on the board, wherein we are given the information that OM is perpendicular to PQ. So if OM, I'm just interpreting the information on the diagram. If OM is perpendicular to PQ, what can you say about the distance PM and MQ?
They are equal
And the reason why are they equal?
because the line from the center bisects the line at the core. Yeah, perpendicular to the. Oh my God.
Yes, yes. So we're given the information there about this line. PM will be equal to MQ because OM is perpendicular to PQ. Okay, then now we are also given that the distance OP is equal to 50 millimeter. We are also given that the distance OM is equal to 10 meters. Then now our task is for calculating, the first question there is for calculating PM, which is this distance that we have there. Is there anyone who have an idea of how we can calculate the distance PM? How can we calculate the distance PM? What are we supposed to use in order to calculate the PM?
Isn't it the Pythagoras theorem?
Very true. We are going to use Pythagoras theorem in this case. And we are motivated to use the Pythagoras because we are told that this is a right angle triangle because we are given that we have a 90-degree there. You see that? Okay, then the implementation of the Pythagoras theorem here is going to be PO squared is equal to PM squared plus OM squared. To make this the sort of formula is going to be PM squared, which is equal to PO is given as 50 squared. You take this aside, it's going to be minus 30 squared. Then from there, you root both sides. You are going to have 50 squared minus 30 squared, of which that gives you an answer of what? Can you quickly do that with your calculator and tell me what you obtain when you put it on your calculator? What is the value you obtain when you put this into your calculator?
40.
You obtain 40. And that is the distance here, 40. Okay, remember, whenever you write statements under this chapter, you give a reason. Like here, we are saying PO squared is equal to that. It's a Pythagoras theorem. So you can say Pythagoras theorem, or you give this reason that OM is perpendicular to PQ. That is enough reason for motivating this. You either say Pythagoras or you write that statement. It's good enough. And then let's quickly rush to question number 2, which requires us to give the length of PQ. This length PQ, what will be the length of PQ? PQ will be equal to what? It will be equal to PM plus MQ. But there is information we know that PM is what?
40.
PM, yes, PM is 40. Yes, very true. PM is 40. But we know PM is equal to something. PM is equal to MQ, right? Why?
Yes.
Can you give me a reason why PM is equal to MQ? Why PM is equal to why PM is equal to MQ?
Isn't it the theorem of the midpoint where the line from the center?
Yes, midpoint. Very true. It's a midpoint. We implement the midpoint here. So otherwise, this was not going to be equal to that if it's not because of the midpoint theorem. So we know the distance PM will be equal to MQ. Why? Because we have a midpoint. I gave you the theorem just now. Therefore, in that case, it means PQ will be equal to 40 plus MQ is equal to PM, which is 40. Therefore, the distance PQ will be equal to 80 millimeter in this case. And those are the solutions we are looking for under these questions. So what did we do here? We implemented the midpoint theorems, and you must take note of the fact that we can only do that if we are given the information up there that OM is perpendicular to PQ. Otherwise, if this information is not given, don't take any risk of applying the Pythagoras theorem and also of applying the midpoint theorem. You are not going to get to the correct answer. So you will need to have the information we are given here. And it's the information that that is given. If you remember very well, we're having a given and then conclusion. So here we are given that OM is perpendicular to PQ. Therefore, we can then make conclusion that if we're given that, we can then use the Pythagoras. If we're given that, we can then use the what? The midpoint theorem. That is very important for you to take note of. Okay, now tell me if you have any problem with regard to the first question I've covered with you just now. Okay, this meeting is going to log off